All right, so we just got physics working, and I think today we're going to do enemies. Something for you to shoot. So our bullets have physics. We can bump into them, and we can often get into this slightly weird state where we're sort of off the ground. And we're spinning and spiraling, spewing bullets into the air. Not 100% against that, but we might want to control it in some ways. And I realized what was... the problem that's causing this is something I spotted in the screw around section of the last episode, or at the end, where I was just trying things, and I realized the way we're setting our velocity here is causing this problem, which is we create a vector that represents what the input is doing, what buttons are being pressed, and then we just set our velocity to that, and we're doing that every update, just all the time. It's not conditional on anything, and so that means when you're pressing nothing, this vector is 0, and we're setting our velocity to 0 all the time. And so if the physics engine bumps us around and we're off the ground, the physics engine is always trying to make us fall under gravity if there's nothing below us, and if we got knocked a bit on the side, then we should have some rotation unless something actually collides with us to stop us. And it's trying to do that, but every frame we're setting it back to 0, and so we have this like slow fall effect. In fact, I'll if while I'm playing I just turn off one of these walls, I can just click on one of them and uncheck it. Not that one. Any one but that one. Then you'll see I'm sort of falling. I am falling, just very, very slowly. And it's because the physics engine is trying to make me fall because I have gravity, because we added a rigid body to me, which means that I'm a physics object now, so gravity affects me by default. But every time it starts to make us fall, we're all just setting it back to 0, and so we have this weird tension of these two things fighting each other. So if we're going to make a game about jumping and falling off ledges and stuff, then we need to really come up with a proper solution to this and go deep on it and get into some technical physicsy stuff to decide when the physics engine should control us and when our controls should control us and how those two things should interact with each other. That's all a bit complicated for this early on, so for now let's not make a jumpy, fally game. Let's just stick to this one plane of action. It's going to be a top-down shooter for now. Something like sort of Geometry Wars, where there's no possibility of up or down movement. And that means we don't have to fix our code because there's a nice and cheap way to ensure that this is not a problem. Because it's a common problem, that things like this are common problems. When you often want not full physics, but like all the good stuff of physics, but with none of the bad stuff. And you get that with constraints. So on our player object, there's under this rigid body. Remember, rigid body means physics object. There's a category called constraints, and we can limit our movement in some ways. And in fact, I'm going to run the game and do this while it's running so that you can see the effect of each thing. Obviously, because we're making the changes at play mode, they'll be lost when we stop, but it's trivial to remake them, obviously. So let's actually, if I turn off a wall again, am I going to turn off the wrong one again? I don't know why I keep getting this wrong. Just either of the last two would have been fine. So we're spinning around like that, and I'll select our player, and let's freeze their position in the y-axis. So now they can't fall. So I will zoom over in Scene View just to show you that. They're not getting any lower now. And in fact, if we scroll up to our y-coordinate, we should see that's fixed in time. And let's just put it back to where it was. No, it was 1, wasn't it? So that's where we want to be. And now that we've frozen y, we freeze position in the y-axis. We can't go up or down. Obviously, we don't want to freeze it in the other axes because those are the ones we move in. And in fact, can I still move? No. And then these other two, we don't want all this rotation really, do we? And you might intuitively think we want to freeze in y. We don't. We actually want to freeze in the other 2 dimensions. And I'm going to have to restart the game to actually show you this. This wasn't as good a live demonstration as I hoped. So we want to freeze in those 2 dimensions because so we freeze position in the y-axis because we don't want to go up or down. We do want to rotate around the y-axis. So y rotation means if we jammed an axle through us from above, then how could we still rotate? Well, we could still do basically this kind of rotation. If there was an axle through us from above, we couldn't move like this, but we can still spin like that way around. I don't know if these hand gestures are going to translate at all. Whereas X rotation means if you jammed an axle through us on the X-axis, how could we rotate then? Well, we could do like a forwards roll at that point, and if you jammed it through the Z-axis, we could roll on our side. Those are the two kinds of things we want to stop, right? We don't want to do forwards rolls, we don't want to roll on our side. We're fine turning, but we don't want to do those things. So we freeze rotation in X and Z, and we freeze position in Y. And that, just to actually play around with it and make sure that it does do what we hope. Now, when we run into a big mass of bullets that's piling up and the physics engine is trying to knock us around, it doesn't do it at all. And if I remove a wall, 3 or 4, remember it's 3 or 4, then, so we do still have some sort of free spinning if there's nothing beneath us, no friction to stop us from rotating, but only in the directions we can already turn in, which is fine. But we're not falling at all. It's obviously looked weird. We don't want to have any drops in our game because it looks strange when this happens, but I'm not being bumped up or down. So that's nice. While we're at it, instead of these all being ground things, let's actually name them. And if I get my camera, I want to get my camera the right way around so that Z is north. And then I'm just going to call it north wall, south wall. Compass directions is a little bit of a stretch to say that these are north, east, south, and west, but it's just whatever you want to make it really. And it's better that, like, left and right obviously has other issues. And Z positive and Z negative is very accurate, but it sort of doesn't have any intuitive meaning. So we fixed our little bug. Now we want to create an enemy. We want someone to shoot. So we've created a lot of cubes so far. I think we should now create a create game object, 3D object. Let's make these capsules. A capsule is like a cylinder with a rounded top and bottom. It's miles away. In fact, let's just enter the coordinates manually and just say 0, 0, 0. Although actually that puts them in the ground, so not quite 0. The capsule is actually taller than our cube. It sort of has a default size that I guess is, does that look like 2? I think it's 2. But the way it works out is that 1.5 y coordinate means they're just touching the ground. I think we should have a new material. We've got material for the ground. We don't actually have a material for the player. They're just, by default, having no material distinguishes them from other things. We don't want the player to have the same kind of look as the enemy. So let's right-click on our project area and go to Create Material. And I'm going to call it Enemy Material. Oops, I put a semicolon in the middle of that name. Okay. And up here in its properties, we can change its color. So obviously red seems reasonable. And to apply it, we select our capsule. In fact, let's name it enemy while we're at it, so we don't forget. And just drag the material over to somewhere in the bottom. And again, you can't drag it on top of the material for some reason. And now because I've done that, it's expanded it. So I've got to scroll down the awkward way. And I've got to drag it to the very bottom of that. Now that it's on there, I actually want to, let's click on the material again and we can just mess around with some of these settings. This is not stuff that I really mess with in my own work because I work with an artist. But if we did want to, there's a slider called metallic. We can make it more metallic. That looks kind of nice. And smoothness, I don't, ooh, goes very shiny. Wow, that looks kind of surreal at the maximum thing, but a little bit of smoothness is kind of nice. It does have a kind of glossy metal feel. And I don't think any of the other settings are as simple to mess around with. I did notice if you ever wonder what specular highlights are, they're here, and if you uncheck it, see what disappears? It's that little bright spot. That's what specular highlights are apparently. It's nice to see those things in action. So we have a shiny blood red enemy. And we want it to do something. I think a good basic enemy behavior, just to get started, is to have them move towards you. Let's say, since we have a gun, let's not give them one and have them just move mindlessly towards us. And that's one of those things where like that is easy to program the easy part is dynamically adjusting their velocity in real time to smoothly track the player regardless of the player's position. That's easy. Knowing who the player is really hard. It's a problem with no really clean solution that's sort of as easy as it feels like it ought to be. So click on our enemy, and we're going to add a component, and we want to add a new script right at the bottom here, and they're going to call it enemy behavior. And once it's finished adding, I'm going to double click it now, and we want the, actually, before we do this, sorry, I forgot, we need to give it a rigid body. So this is going to be a thing that's moving in real time. We want to change its velocity, and for that we do want a rigid body. Actually, I should just, I've got the word rig typed in here, and that's why it's only showing me a limited number of things here. So when you want to add something, you can just type rigid body and it'll come up. And in fact, yeah, you should do that, because navigating through these menus is a pain. So it's got a rigid body now, but it's the behavior we want to edit. And we're going to do this in its update, because we want it to be changing all the time. As the player moves around, it's going to adapt its velocity. And the first thing we need to do is get a reference to our rigid body, which actually, is that the first thing we want to do? Yes, it is. And we've already done that. We've already done that for bullet behavior, we've done it for player behavior, and it's this line here that says, declare a variable of type rigid body. We're going to call it our rigid body, and the thing we want to save is a component on this game object, that's of type rigid body. And we can just copy and paste that into our update. And then we're going to write something like, I'll do this as a comment because we're not going to write it yet, but our rigid body dot velocity equals some kind of vector going towards the player. And the player is the tricky part, because how do we reference that? How do we refer to the player's behavior? The enemy needs to find out where the player is. And ultimately, when this game, depending on what kind of game we're making, if we're making a stealth game, the enemy's going to have like a vision cone, and we'd have to model that, and we'd have to do some maths about whether the player is like scanning that whole area and detecting all the objects in it, and then saying, is that a player? Is that a player? Is that a player? If we're making, I used the example of Geometry Wars earlier, which is like a just top-down action shooter. I'm pretty sure in that game all the enemies know where you are at all times, so you wouldn't program any kind of detection logic for the enemies, because if it's not going to be a factor, you don't need it. And in that, there's probably some way that they have like a global reference to the player. How exactly we end up doing it, I think I know how we will do it eventually, but it's a little bit, it sort of requires learning a whole new concept, so I don't want to do that just yet. For now, we're going to do it the most basic way, which is the same way that players refer to the bullet prefab. Remember, we declared a public variable of type GameObject called bullet prefab, and then we were able to just drag the bullet prefab from the project folder into our player so that it knows what a bullet is and how to create one. We're going to do something similar here, but this time we are not going to give it a reference to something in the project folder, an asset. We're instead going to give it a reference to an actual object in the scene. So right up top in our enemy behavior, this is in the loudspeaker area where you get to declare things that apply to the whole script. We're going to declare a public variable type GameObject, and we'll just call it player. And now that we've done that and we save it, when we go back to Unity on our enemy, we should see that there is a little slot here for player once it figures out what's going on. And it's set to none for the moment, but we can just find the player in the hierarchy over here and drag them over into that slot. And now the enemy has a reference to the player. So I guess that wasn't that hard, but I'm coming from a game maker where I could have just typed a global variable name and it would have all been done for me. The way we'll eventually end up doing it is, well, I guess I'll cover that when I do it. But for now, we have a reference to the player. That's all we need for now. We just want to get some behavior working just to see how it feels and decide what kind of game we're making. So we are indeed going to type our rigid body dot velocity equals, and now we need a vector that is represents what direction and distance we'd have to travel to get to the player. And the way to figure that out is we take their position, player dot transform dot position, minus our position, transform dot position. This is one of those, it's a very common thing to need to do when you need to know, tell me the difference between these positions, or specifically tell me how to get from A to B. And the answer is it's always B minus A. You always start with a destination minus the origin. And that feels slightly backwards maybe, or it's just, it is kind of backwards because, a journey starts with the source and then arrives at the destination. This line of code, the destination comes first and the source is afterwards. I am just going to explain why it's that way around, just because this is maths, not programming, but it's one of those things that sort of it comes up a lot, so it's worth just sort of having it straight in your head why it's the case. So in scene view, this is our enemy. Our player hopefully is at 0, 0, so x and z are both 0. If our enemy is at, let's say, let's put them at 4, 2, and the enemy wants to get to where the player is. This is the vector we're looking for. In fact, I can draw it with this. They want to go there. Then they've got to get from 4, 2 to 0, 0. And how do you change your 4 into a 0? You have to reduce it. You have to, if I move them, is this the right direction? Yeah. As I move them towards the player, you can see their 4 gets lower. It's reduced. So if you're at 4 and you want to get to 0, you have to travel minus 4, which is 0 minus 4. If the player, and in the z dimension, we're at 2, we want to get to 0, we have to travel minus 2. Start at 2, we need to be 2 less than we currently are, so it's subtract 2. So that is why it's negative our position. And yeah, if the player was at, say, 1, 1, and we're at 2, 2, how far do we have to travel? We have to travel minus 1 in that dimension, and then minus 1 in that dimension to get to where they are. So that will run. What we've written there should work, I think. So let's just see what that looks like right now. This isn't... Oh! I didn't anticipate this. So this is working. This is doing what we hoped, but I forgot that we didn't fix their rotation. They're not frozen in space and time, so they're just like, the velocity is pushing them over, but because they're not a nice stable cube like us, they're falling all over the place. We can bump into them. I'm not going to fix this. I like it. I think that's great. I didn't have a reason for making the capsule, but now I do. Now I think it's a great idea. So there is something a little bit odd about this behavior, or it's actually fine. I think this kind of feels all right, but look how slow they get when they get close to us. They chase us really well when we're far away, and then they get close, they sort of seem to almost lose enthusiasm. Like, I've basically caught him now. What's the point? So we can make them less lethargic. Do you know why it's doing that? Do you know why it goes faster when you're further away and slower when you're close? It's because we set their velocity to basically the distance between us. Like, it's not just the direction, it's also the distance. It's the entire journey you would have to take to get to us. That's your velocity. And you might remember that velocity, when you set it, if I set it to 1, that's 1 meter per second. If I set it to 2, that's 2 meters per second. So we've set it to however far away we are, meters per second. So when we're 5 meters away, we're going 5 meters per second, which is pretty fast. But we don't stay at that speed because next update, we're closer now. So now we're shorter distance, less speed, and so it gets slower and slower. That's not what we want. There are times when you might want to do, this is actually basically rubber banding, which is a thing you might see in like racing games, and where if you get really far ahead of the AI, they just make the AI faster so they get close to you, but then once they get closer to you, they'll go slower. So there actually are some legit reasons to want things to behave this way, but right now we have no control over it. It's just like, that value is kind of set in stone. And I think we just want to fix velocity because it'll be hell to balance that. I think for now, we're just trying to make quite a simple game. We just want everyone to move at a fixed speed. So what we want to do is we're going to do something to that vector before we set our velocity to it. So we're actually in the line above, we're going to declare a vector3 variable called vector to player, and that is going to be exactly what we typed there. That's just the exact same thing we were talking about before, but rather than directly setting the velocity to that, we will do vector to player dot normalized. Normalized means shrink it down to be 1 meter long, basically. So same direction, don't mess with which direction it's going, but just make it always 1 meter long. And in fact, not just shrink it down, but also if it's less than 1, grow it up. Make it exactly 1 long. So that eliminates the distance factor. Now, it doesn't matter how far away it is, we're still going to get the direction, but we're just going to fix it. And that would make us move exactly 1 meter per second towards the player. I could show you that, but you don't need to see it to understand that. Or to understand what we want to add to that, which is we probably want to vary the speed, right? We want to be able to set the enemy speed. And because that's the kind of thing we might want to tweak at runtime, let's do it the same way we did everyone else's speed, which is a public float called speed. And we're not even going to say what it is here. We're just going to rely on the fact that when we go back to Unity, we will see a slot pop up there for speed. And I'm going to try 4 as a starting point. I don't really know what that's going to feel like. And then we actually haven't applied that yet. So on this line of code where we set the velocity to the normalized player vector, it's actually not just going to be the normalized one, it's going to be that times speed. So that's, forget how big the vector is, make it just 1 long, and then do care about how big our speed is, make that be the actual distance, the size of the vector, the speed, if you will. So that should now be a steady speed of 4, and we can tweak it in runtime to see how, see what feels right. I love that they tumble over, it's so good. So actually, I can't remember if I explained this, but I could just type numbers in here, but I typed A6, that's not a valid velocity. But you can actually, if you click on the word speed or just anywhere to the left of the number, you can actually sort of drag it like a slider. So you can do that for any value, any number in Unity. So we can drag it all the way up to like 20. And then I'm going to click back in the game to, oh my god. He's so fast, he's making me faster. He's actually pushing me towards where I'm going. 20 is too much. Let's try 10. 10, that's all right. I'm still faster. I think we're 20, aren't we, the player? But it feels threatening. It's coming towards me for sure. And I'm trying to shoot it, but it's easier said than done because we can only shoot in the direction we're facing, and also because it's a weird shape and it keeps tumbling out of my way. I think I like that speed. We could try 8, I guess. But remember, all these changes we're making are going to be lost because they were making them at runtime. Yeah, 8 is not too slow. I think that's good. Oh, it can trip on our bullets. That's great. Okay, so the next thing you might want to do with enemies is make more than one of them. And so we could just duplicate our enemy, but if we do that, and I'll show you what I mean, you can right-click and say duplicate. I just did Control D there. Now, if we start making changes to one of them, well, if we change our minds about how we want enemies to work, we're going to be making changes to a single enemy at a time, and that is going to mean that they then behave differently. They also start in the exact same position, which was not intended. So one of them is now moving faster than the other because I increased it. And if I increase it at runtime, now one of them's going very fast, the other one's going very slow. And yeah, if these two things are meant to be the same, let's tell the game that's what we mean. So let's not duplicate it. I'm going to delete that duplicate. With our original enemy, we just drag it to the project folder. And now it's a prefab, just like our bullet is. You remember we made a bullet. We actually made that in the scene and then dragged it to the project folder to make it a prefab. In the case of the bullet, that's just the abstract. We didn't want a bullet to be in the scene at startup. We just wanted that to be an idea that the player has in their head that they can not the player really, but the player behavior knows about, so that it can create a bullet when it needs one. It knows what it's creating. Case of the enemy, we are making it that kind of thing. It's this sort of like ideal concept that's never going to change and is set in stone and could be created at runtime while the game is running. But in this case, it is going to be in the scene. And if we want another one, we can duplicate it, because now that it's a reference to the prefab, it's still true that if I edit the individual values of this instance, it will only affect this instance. In fact, let's just, again, I've started them in the same position, which is not what I want. I mean, they get out of it because they're physics objects, so they find a way to resolve it. But yeah, it's still true if I up one of their speed, it only affects that one. But if I do want to affect them all, then I can double click the prefab in the project folder, and we go into this. Remember, it's like you're in the matrix when you're editing a prefab. It's just the prefab, nothing else. That's good. That tells you you're in the right mode to edit this thing. And now if I set that to 10, we should find all our enemies are move at the same speed, and it's 10. They remind me of those like sort of executive toy magnets you can get that, they're very satisfying shapes. They really like stick together really strongly. There's no code telling them to stick together. They're just both in the same place doing the same thing. So, and in fact, maybe that's the thing we should change right now. Let's not make them spawn inside each other. That was stupid. But what the hell? Let's have a bunch of them. I just hit Control D there to duplicate it, and I'll do it again. And now we start surrounded. They all come towards us really fast. 10 is too much, definitely. And then pretty quickly they clump up again. That's kind of cool in itself. Actually, they're like red blood cells, aren't they? This could be like a sort of microbe scale game. Oh, it's horrible when they mob you. They can almost like trap you and lock you in. Oh, that feels so bad. In a good way. Like it's a fate you want to avoid. So that's cool, but yeah, like I say, I want to edit their speed, so I'm going to open the prefab to do that, and I think we decided 8. The other defining feature of enemies, other than mindlessly moving towards you, is that they should be affected by bullets. We're making such a conventional game, but we have no shame about it. So to do this, we want to detect when a bullet hits an enemy. For now, bullets are only going to hurt enemies and not care about anything else. That's the only collision we're interested in. If we could put that bit of code on the enemy or on the bullet. I think it makes more sense to put it on the bullet. So either a bullet can be checking, did I hit an enemy, did I hit an enemy, did I hit an enemy, or the enemies could be checking, did a bullet hit me, did a bullet hit me, did a bullet hit me. I think eventually our bullets will only exist for the time that they're flying. They'll hit something and they might catch onto the ground or something, but then they'll fade out, and their existence will be brief. And all of the time the bullet exists, you want to be doing that check. You care about whether it's hitting something. It may not be true that all of the time an enemy exists, we need to be worrying about bullets. It makes more logical sense to me to put it on the bullet. This is one of those things, it's a matter of opinion, but I think that makes more sense. So in our bullet code, it's also kind of nice because our enemy behavior is probably longer than our bullet behavior. That's not really the way you should make these decisions, but it is kind of nice if you don't end up with one massive class and a load of small classes, scripts, bullet behavior, the functions it has right now are what to do on start and what to do on update. I think of these as events. I don't know if that's a name that's actually officially used, but these are functions that will be triggered at a certain point when something happens. In this case, when the thing is created, and in this case, all the time, like every frame. And we want a new one of those. We want an event that triggers when a collision happens. And there is one already that Unity already knows about, and it's called onCollisionEnter. So I'm going to write onCollisionEnter, and it's going to tell what I mean. And when it does that, I'm going to hit enter, and a whole load of code appears. I hope this happens in your Visual Studio too. I think it will. It knows not only that I wanted to write onCollisionEnter, but it also knows all the other stuff I've got to say around that, like private void and all this stuff in brackets, which is great because I would not remember that. I remember the name of the function, but that's it. And even if I've forgotten that as I'm typing it, even if I got it wrong, it would you'd be able to see that it's this. So the name on collision probably sounds pretty logical. The enter part is a little bit less logical. That there's we're not going to use this, but there's on collision exit as well. So a collision, in our case, they're things bouncing off each other. So in our case, they don't really enter each other. It's really just saying the first time they touch, and technically, whether you call that them entering each other or not is kind of semantics. But that's why the word enter is there, and it's not just on collision. On collision exit would be something passes through something and then it leaves it. So when the collision happens, we want to destroy the enemy, if it is indeed an enemy that we collided with. Just to sort of show you that that this is working, I'm going to write destroy brackets game object. So this just says kill us, destroy the whole game object we're on. When I write game object on its own, that means I'm referring to, with a lowercase g, I'm referring to the game object that we're attached to, in the same way that when I write transform, that refers to the transform that's on the game object you're attached to. And destroy, pretty intuitively, destroys whatever you put in those brackets. So I'm doing this just to show you that this will detect collisions already. There's a difference between, sometimes we're going to be writing functions that we just made up. We just think of something and do it. So now when I fire bullets, anytime they hit anything, they're just disappearing. They're not bouncing off it. They're not clattering to the floor. That happens when the enemies are smothering me. And actually there's a weird thing happening where when I move forwards, it's like I've got a pneumatic drill or something rather than a gun. I think the bullets are hitting each other because my velocity is, it's not being added to theirs, but it's the next one created is closer to the last one because of the way I'm moving. And so they're hitting each other and destroying each other. So that's not what we want, but I just wanted to show that works. What we want is we want to know what we collided with. We don't want this to happen on every collision. We don't want something to happen when we collide with an enemy. And so we need to know something about what we collided with. And that's what this word collision up here is for. So what this is really doing is declaring a variable of type collision with the name collision. Because of that, I'm actually just going to change this name. I'm going to say this collision. And I'm doing that just to make it clear to you that this is the name of the variable, this is the type. I find it weird when they just write the same word twice. It makes it harder to understand what's been written. So this collision is just the name, you can write whatever you like there, but it is a collision type variable. So in the same way that this rigid body, our rigid body its type is rigid body, this thing is a collision. What is a collision? It's a bunch of data about what just happened. So when we write this collision and put a dot there, there's all these different things we can get. So we can get contacts, we can get type, we can find its relative velocity, we can get its rigid body, but actually up here there's game object, and this collision.game object will tell us, will get us a reference to whatever the object is that we hit. And remember how when we wanted to know if we had a rigid body, well, we actually wanted to find our rigid body, we did get component. We're going to do that to this game object we found. We're going to say, this game object, get their component, and the type we're interested in is enemy behavior. Because if this thing has an enemy behavior, then it's an enemy. So that's how we're telling. When we collide with something, we say, hey, do you have an enemy behavior component? Because I'm on the lookout for those things. And we're going to do something if it does. That is not quite what we've written right now. All of this is just a reference to that, to whatever the enemy behavior they have is. So we want to check whether this thing exists. And I guess we can just do, if we do if and then brackets, all of this equals null, close brackets, and then we do these curly braces for what happens with the if. This is, in case it's been a while, all the way back in the player behavior. Remember we did if this button is being pressed, then do this. So we have regular brackets for what it is we want to check, and then we have these braces for what it is we want to do if it's the case. And so the same syntax here. So if all of this thing, right now I said equals null, null is what will happen if this thing doesn't exist. If you say, hey, what's the enemy behavior of this? And it doesn't have one because it's a wall, it will come back and say null. So right now we're actually in the opposite of what we want. We don't want something to happen if the enemy behavior doesn't exist. We want something to happen if the enemy behavior does exist. So we don't want to say equals null, we want to say not equals to null. And the way you write that in this language is exclamation mark equals. So exclamation mark equals, you read it as not equals. So this just says, find their enemy behavior and check whether it's, and tell me if it's not null. If it's not null, we want to do something, because that means they're an enemy. And in fact, what we will do is we will destroy ourselves, but we'll also destroy them. We'll destroy them first, I think. I don't know if it'll actually break if you do it the other way around, but it certainly makes more sense to destroy them first. So destroy brackets, this collision dot game object. So we already referred to that, didn't we? We've got that game object. And now we just want to destroy it. And in fact, I might just make a little change to this, this is just something that I would normally do if I'm going to write something like this. Because we refer to this game object twice, we might as well make a variable for it and save it. So declaring a new variable of type game object, and I'm going to call it their game object. And that is going to equal this. So new variable of type game object, call it their game object, and it's this collision, the game object. Whatever game object we just hit. And then I can replace that here and here, and I slightly typoed that. And that also makes this line of code is getting kind of long, and I just wanted to make that a little bit clearer what we're doing there. There's one fewer levels of complication there. So yeah, their game object is this thing. If that thing doesn't, if that thing, it is way written. It is kind of weird because it says, what this really says is, if it doesn't not have an enemy behavior, we are saying, look for an enemy behavior, and if it's not null, if you didn't fail to find one, then do this. There's a way to avoid that double negative, but I think it's weird in its own way, so I won't teach you that. And I'm trying not to, as I said at the start, I don't want to teach you multiple different conflicting ways to do the same thing where possible. This works, and not equals is a useful thing to know. You'll need this a lot. And not equals to null is actually a really common thing. Because another thing we might want to do is, it's quite common, don't write this because this is just me illustrating something, but it's quite common to do something like, if their game object is not equal to null, then we're going to do something to their game object. Game object, I don't know, set their position to something. And you've got to check that it's not null before you do that, because if you try and do that to something that doesn't exist, you hit a crash. So this is a really common thing to want to write, if this thing is not null, let's do some stuff. So it might seem a bit weird, but you are going to have to get used to that. So this is not a bad way to do it. So this is going to happen every time we collide. We look at what we collided with. If it has an enemy behavior, then we destroy them and us. We could make it so we don't destroy ourselves, but there's something sort of intuitive. The bullet's kind of like absorbed. So it's actually very difficult to shoot them because you fire in the direction you're running and you want to run away from them usually, but that works. Look, our bullets are bouncing off the walls and they are not killing. No, wait, they are killing the enemy. Bouncing off the walls, killing the enemies. Exactly what we wanted. So that's it for this lesson in terms of the actual things we wanted to teach. I do want to mess around with this a little bit as well, because our game is very annoying to play right now. We've made a game that it kind of has a nice feel to it, but then actually like shooting things is hell, because you can only shoot in the direction you're moving, and that's the last direction you want to shoot in. So let's play around with what we can do about that. I don't know what we'll actually do in like the next lesson to fix that, but well, I know what we want to do. I want you to shoot at the mouse, but that's too complicated to do right now. So for now, if we go into the player behavior, so this is the part that spawns a bullet, and it spawns a bullet prefab at our position plus a bit forward and at our rotation. If I change that to minus forward, now it's going to spawn behind us, so that's a start, but it's still going to be facing the same way as us, so that would shoot us in the back, which wouldn't hurt because the other bullets don't hurt us. But actually, no, this is a screw around session. We should see that. I want to see that happen. They might just go straight through us. I can't remember if we actually if bullets collide with us or not. Oh no, they do collide with us, don't they? So, wow, what the hell? They propel us. I'm not pressing any direction keys there. That's all the bullets. Excellent. Oh, I'm so glad I tried this. And that was super effective for destroying the enemies. Because actually our bullets don't care how fast they're going. So I bet if we left a trail of bullets, they would almost be like landmines, because the enemies would die as soon as they touch them. Like, I wonder if I can make that happen intentionally. Can I lure them into these bullets? Yeah, look at that. It deletes a bullet when it happens, so there's only one bullet left and one enemy. Oh, he waggled over it. You got to make them roll instead of waggle. Well, that's great. I don't know if we need to do anything else. Bullet propulsion. Just shooting myself in the back. It's interesting. You go in a kind of chaotic direction, I think, because there's just like everything's colliding. Bullets are colliding with each other. They're, clattering in all kinds of directions, so their actual force gets shifted around in all kinds of ways. What I was going to do, which now seems a lot kind of boring by comparison, is change their rotation as well. And this is something that you don't really need to understand yet, but if I want to look backwards, I can do quaternion.look rotation. Quaternions are how rotations are stored, and I'll explain them in a future lesson. Well, I won't explain them because they're nightmarishly complex. But it's just a data type, and it means rotation. It's a type of rotation. And in this particular case, we're calling the quaternion hotline, and we're going to ask it, what would be the rotation for if I wanted to look in this certain direction? And instead of forward, I'm going to do minus transform.forward. So that's the opposite of forward, just the other direction to forward. So that ought to make them fire behind us. Yeah, wow. That's a lot more precise and effective. In a future lesson, we'll give these enemies health, and so it will take a while to kill them and stuff, and so and we might reduce your rate of fire a bit. Right now, it's kind of all over instantaneously. But yeah, that feels promising. Shooting backwards game could work. Like I say, I'd like us to aim at the mouse, because then we've got two axes of input for the player, and that's more interesting. So another thing I wanted to try was the player has this slot for a bullet. What if we put the enemy in there? What if we fire enemies? I think... let's find out. Oh my god! Oh no! Oh, wow, they actually ended up standing up. Hey, this is actually slowing down. We've successfully made the game kind of chug. Remember how many bullets we could have without any slowdown? But with just this many enemies, we have an issue. And I believe that's because they're all doing stuff with... like they're all adjusting their velocity all the time. Does that make sense? It may just be because they're capsules instead of cubes, and the collisions between them is more complex. Capsules are actually a very commonly used type of collider in games. When you are, like in a first-person shooter, your character is probably being treated as a capsule in a lot of cases. And they have a few nice things where, they sort of vaguely match the sort of broad shape of a human, but also the curvy bottom part means that when you're going up like very small steps, you're not constantly catching the edge of your collider. Instead, it's sort of like it smooths some things out kind of for free. And I thought I was just guessing, but I assumed part of the reason was that I thought they were very efficient to calculate collisions because on the maths side of things, if you're in like the cylinder part, then all you're measuring is how far away you are from like the core axis, and if you're at the top, then all you're measuring is how far away you are from that top of that axis, because a sphere is I don't know what that's supposed to tell you, but anyway, that's what I thought. In practice, we're seeing like a big performance hit from having a whole load of capsule colliders around, which is curious. This is not the game we were going to make anyway, so I think we're good on that. But it's fun to mess around with this stuff.